All right. So we've started off kind of going through the idea of inheritance. This video is going to cover the concept of polymorphism. Now, polymorphism is not that complicated, but it's kind of funky because the questions that you're likely to see on any of the tests for AP, um, you got to know the concept, but at the same time, um, you would never program like this um, with what we're showing you. You'd actually use an array, and I've got that in examples videos later on. But let's go through kind of the idea of polymorphism and what's going on. So at the top, we have a student, and there's a grad, student, undergrad. Grad students inherit from student, undergrad inherits from student. The student has name, test, and grade, right? My name, my test, my grade. They can get the name, get the grade, set the grade, and compute the grade and get the test average, all right? Let's see here, set grade. Okay, cool. So the undergrad knows all the methods above, except it overrides the compute grade method, and it knows this at runtime which one to call. Okay, if you have an undergrad. So let's get into this and look at the grad student. Grad student supers in the name, the test, and the grade. And a grad student also has a graduate ID number, and it can get the ID, okay? And then it also overrides compute grade, okay? It actually calls the student compute grade, and then it also implements its own information where if you get the test average and it's greater than 90, then you pass, okay? Where it gets a little bit funky with polymorphism is something like this, okay? Now, let's look at this. You have an object S. A student is a student, okay? And you kind of read these backwards. A grad student is a student. Now, a student is a grad student? Not necessarily. But all grad students are students, okay? And all undergrad students are also students. All undergrad are also students. So you can define these out, and these are perfectly acceptable. You would not do this like this in real life programming. These are just examples that we need to go through first before I show you what the real life example would look like, okay? Because ideally what you would have is you'd have a student array with, you know, student objects in them, and then grad student objects in them, and undergrad student objects in it, okay? And then you could loop through your array to read through each one. And so what needs to happen with polymorphism, what it allows you to do, if you have an array like that, when you run it at runtime, you know, there's something called dynamic binding that occurs, and it knows what methods to call for each object, okay? So you can call these methods s dot, s, g, and u, and they all call set grade, and they're all pass, okay? That is fine, because remember, all, you know, a grad student is a student, so a grad student knows the methods of a student. An undergrad is a student, so it knows the method of student. That's the purpose of inheritance, okay? Okay, let's look at this now. All right, so a student knows how to compute the grade. This will use the compute grade method in the student class. G.ComputeGrade will use the compute grade method in the grad student class, and U.ComputeGrade will use the compute grade method in the undergrad class. This occurs because of overriding, okay, and dynamic binding, making a runtime decision about which instance method to call, okay? So each of these are different methods, and at runtime, the compiler has to know which one to call, okay? An undergrad would want to, do the compute grade that an undergrad gets. A grad student would compute the grade that the grad student gets, and a student would compute the grade that the student gets, okay? Where we have issues, okay, s.getID, g.getID, and u.getID. Well, wasn't getID in the grad student? Grad student, getID, okay? So let's look at this real quick. And this is kind of confusing. Student and undergrad, they are not necessarily grad students, so they cannot get the idea, okay? That makes sense. No problems there, okay? Where kids they have problems, and when I know they don't know this topic perfectly, they go, wait a second, Seeley. They go, I'm looking at the code right here. Grad students should be able to get the ID. Well, remember, this is how a grad student was created. A grad student is a student. Okay? You have issues because, well, let's just read this. The getID method is not in the student class. And so the only way you can use those, a grad student can use methods, it only can use the methods of the student class, or it can use the methods that are written in its own class as long as they're overriding the method that is in the student class. Okay? So, let's read here. On each of these, I receive an error. Neither student S nor undergrad U inherit the getID method from the grad student class. Those make sense. Why then do we receive an error when we call g.getID? GetID does not get created in the grad student class. It does get created in the grad student class, but since G only knows methods in the student class, it cannot execute g.getID. In order to execute getID, the object G would need to be created as a grad student. So you would have to go back and recreate this right here, okay? And again, if you were to write your code out in real life, it would look like this. You would never write your code out. You would never do this right here. Ever, 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 ever. You would never do that in real life. But I have to demonstrate this to show you what's going on. You wouldn't write it out like that. What you'd have is you'd have your separate objects, and then you would store them in a student array. Okay? And I've got examples on that, okay? Let's look at these sample questions. So redefining the withdrawal method. Okay, redefining the withdrawal method in the checking account class is an example of, well, let's go to the top and let's look at these bank methods again. Okay, so bank account has deposit, withdraw, get balance. Savings account has add interest, but it knows all the ones above. And a checking account's a bank account, and it withdraws. So this is where polymorphism would occur, I'm guessing, because it overrides the withdrawal method in bank account. If you created a savings account as a bank account, add interest, you wouldn't be able to do that because bank account doesn't know add interest. Bank account knows deposit, withdrawal, get balance. So those would be the only methods that savings account would use if you create a savings account object as a bank account. That's just something to kind of look out for. I don't know what the questions are here, but I'm going to go down and look at them. So, let's see here. Shoot. Alright, redefining the withdrawal method in the checking account class is an example of overriding, because if checking account I don't think it does have a withdrawal method, but if you create your own withdrawal method in it, and it would override the withdrawal method in the bank account class. Oh, it does right here. Bam. It overrides it. Okay. It just doesn't show the implementation of it. But right there, that's your withdrawal method for a bank account. But if you use a checking account, it would override it if you called the withdrawal method. That's also where polymorphism would be checked, I believe. Let's see here. Because you'd have like your dynamic binding going on, and you'd have to know which one to call, which withdrawal method to call. So you got a bank account, you got a savings account, and you got a checking account. Which method call will cause an error? Banks know how to deposit, so that's fine. Savings accounts know how to withdraw because they inherit from a bank account. A checking account knows how to withdraw because, and this is where you're at override in a checking account. Savings accounts also know how to deposit. A savings account is a bank account, so a bank account doesn't know how to add interest, but a savings account does. This would create an error. The way to fix this is if you change this savings account S equals new savings account, and then that error would go away. But since bank account doesn't know add interest, you can't use it. Okay? So the add interest method is defined only in savings account class. It therefore cannot be invoked by a bank account object. The error can be fixed by casting it S to the correct type. Yeah, you can do that. I would have just done this. I would change that to savings. Okay. 3. In order to test polymorphism, which method must be used in the program? Well, remember I said withdrawal, right? Because withdraw, you would be overriding it in the what method or what class? The withdrawal method is the only method that has one implementation in the superclass and a different implementation in a subclass. Polymorphism is a mechanism of selecting the correct method from the different possibilities in the class hierarchy. Notice that the deposit method, for example, is available to objects of all 3 bank account classes, but it's the same code in all 3 cases, so polymorphism isn't tested. 4. Which of the following will not cause a class cast exception error? Yeah, you guys can read that. More importantly, yeah, go ahead and read that. I kind of want to draw some of this stuff out for you guys real quickly and go through. Let me see here. How many more of these are there? I want to kind of draw and get you guys thinking about how to think about these methods and do them quickly in your head so that you can think about where the polymorphism is occurring. Let's look at this one. A new method is added to the bank account class. So bank account knows how to transfer now. So bank account would withdraw and the deposit. A bank account. You can transfer from a bank account to the time savings account. Seems fine to me. Dana is a checking account. So no polymorphism is occurring because this is a bank account, savings account, checking account. So these all look good. It's no problem. All right, let me open this up. And so all right, so let me draw this out. All right, so you had at the top, you had a you got a bank account. And a bank account knows how to deposit, withdraw, and you had the savings account. You had the checking account. Okay, this one withdraws. Okay, this one adds interest. Okay, now this withdraws. So this one withdraws, and then this one withdraws. Okay, so you have to know that if a checking account is created as a bank account, okay, you know that at runtime it's going to call that withdrawal method because this withdrawal method has a fee to it. So it's a little bit different than this one, okay? And you know that if a savings account is created as a bank account only knows deposit draw, so this cannot be used, all right? So those are like basic bread and butter type questions that you'll see on these AP test questions. And so you're going to want to really think about that and know how that works, okay? Again, this occurs, it knows this because of overriding or dynamic binding. Okay, so at runtime it goes up, use this withdrawal method instead of this withdrawal method, okay, because it's a checking account. All right, at the same time, add interest is not in here, so it cannot use this if it's, you know, if it's a bank account Z equals new savings account. Okay, Z dot add interest does not work. That does not work because bank account doesn't know add interest, all right? So those are some basic things you gotta remember, okay? With that, let me see, I believe this video is about done. The next video I think I'm gonna go into is abstract classes. I'll just make a separate video of that, okay?